Welcome back to lesson 1.4, midpoints and bisectors. Let's go ahead and start with the midpoint formula. I have this foldable right here, which I will attach to the lesson if you so choose, but you don't have to. You can simply follow along. Here is my midpoint formula. It's on the front, M for the midpoint, and then you see our midpoint formula. I'll talk about it when I get inside the foldable. Okay, so the midpoint of a segment is the point that divides my segment into two equal parts. So here's my segment AB, and we'll do an example about those specific points A and B later. Its midpoint is the one that's exactly in the middle. It's not between, it's right exactly in the middle. That's the word for the middle, midpoint. Okay, so if I have my 2 points, A that's x1, y1, and B that's x2, y2, then the points, when they're on the coordinate plane, my midpoint for segment AB has these coordinates. x1 plus x2 divided by 2. y1 plus y2 divided by 2. So I'm using my pink pen to make it stand out the parts of the formula, and I'm making the blue one to show this is where the numbers are going to go. So my numbers for x1 and y1, they're going to get split here and here. My numbers for x2, y2, they're going to get split here and here, because remember, an ordered pair always has an x and a y, never an x and an x. Okay, so let's go ahead and look at the first problem, which is find the coordinates of the midpoint of AB with the endpoints -2, 3 for A and -4, -2 for B. It's wanting me to find the midpoint. It's very important that you know what you're being asked, because I can ask you to find an endpoint, and we're going to do that in the second one. All right, the first thing I would do is label x, y, x, y, okay? You always need to label it x and y, just like you did in algebra. I'm trying to get that y off there. There we go. Then you're going to come back to A, and you're going to say 1, 1, because remember, the ones are always together. And then we're going to say 2, 2, because the 2's should be together. Okay, it's kind of like they're a married couple. Now I'm going to go ahead and place it in my formula up above. So x1 -2 plus x2 -4 divided by 2. I simply got this from my labeling. So I used my formula x1, put it in the formula. X plus x2 plus x2, put it in the formula, divide by 2, divide by 2. Comma, because now we're going to do it again before the y's. So y1 is 3 plus y2 is -2. Divide by 2, because that's the formula. Okay, now I'm going to go ahead and do some adding. -2 plus -4 is -6. So I have -6 divided by 2. I think I know what that simplifies to. And then over here I have 3 plus -2. That is +1 divided by 2. I don't think I know what that simplifies to. All right, -6 divided by 2 is -3. And 1 divided by 2 stays the fraction 1/2. Could you change it to 0.5? Yeah, but most of the times I don't use fractions anyways, so it's fine to leave it as a fraction, okay? Plus your algebra teachers prefer it that way, okay? I do want to show you another way that you could do this. Let me go back up here. You could do this simply by counting. Remember how you used to do the rise over the run? You found the slope? Do that here. So count up 1, 2, 3, 4, 5. And then count over to the side 1, 2. Now, don't worry really about positives and negatives because geometry really doesn't worry about that. So you simply want to know how many spaces are between. We want the midpoint. We want the one that splits it into 2 equal parts. So I'm going to take that 5 and I'm going to divide it by 2 because that'll give me 2 equal parts. Well, 5 divided by 2 is 2.5, 2.5. So I'm going to go 1, 2.5, and I'm going to stop. I'm just kind of eyeballing the middle right now. Then half of 2 is 1. So I'm going to go 1, there's my point, and take a look. -1, -2, -3, and a half, comma half. It works that way if you happen to have graph paper available to you, okay? All right, the other way that I could ask you is by saying one end point of segment RS is at the point R5, -3, and the midpoint is M2, 4. Find the coordinates of the other endpoint S. Notice this time when I highlighted it, it did not say find the midpoint. It said find the other endpoint. I'm going to show you how to do this algebraically really quick, and then I'm going to show you how to do this on the graph like I just showed you right there. Okay, my endpoints are going to be my X1 and my Y1. So R and S are my endpoints, X1, X1, Y1, X2, Y2. But M is my XM, YM, because it's my midpoint. So if I use my formula, the 2 and the 4 are going to go where M is, and then the X1 and the Y1 are going to go where the X and Y are. Now, I'm going to split the equation. So I'm going to say the X value of the midpoint equals X1 plus X2 divided by 2. So what I did was I took my formula, I took my midpoint formula, and I took only the X value side, and I set it equal to the X value of the midpoint, okay? And I'm going to use that as one problem. Then I'm going to take the Y value, the Y part of my midpoint formula, which is this, right? And I'm going to set it equal to Y of M. Okay, I hope that makes sense to you. So instead of having a capital M for these two, I've split them into an X of M and a Y of M, and then I've taken my midpoint formula and I've split it into the two separate ones that we did in the commas above. Okay, now XM is 2, so I'm going to put a 2 here. X1 is 5, so I'm going to put a 5 here. Plus, I don't know X2, so I'm going to make it just X. You could leave the 2 if you want, but it doesn't have to be there. And I'm going to put the 2 there. We can solve this problem. Let's go ahead and do that. I'm going to multiply by 2 because I don't like this double fraction. What I do to one side, I have to do to the other. So the first step you're always going to do when you do this problem is multiply by 2 once you get all your numbers in there. 2 times 2 is 4 equals 5 plus X. Now I'm going to simply subtract my 5. 4 minus 5, -1 equals X. There's the X value of my S coordinate. This is the X value. I'm going to go ahead and just put an S there. This is my X value for S. Now let's go ahead and do the same thing for Y of M. Y of M is 4. Y1 is -3 plus Y2 from my formula, but I'm going to drop the 2. I could change it to S divided by 2. Same thing. I see that fraction. I'm going to multiply by 2. Multiply by 2. 2 times 4 is 8 equals -3 plus Y. I'm going to add my 3. Add my 3 to the other side. 11 equals my Y of S. So what is my ordered pair for S? -1, comma, 11. There's my answer for the S coordinate. Woo, that's a lot, and I know that's a lot. I'm going to show you a quick way that you can kind of cheat a little bit and get the answer faster, and it involves using a graph, and it involves using that concept of rise over run. Let me zoom out just a bit. There we go. Okay, so M is the midpoint of AB, of segment AB, with A at 0, 1, A at 0, 1. Actually, you know what? Let me grab a pen so that this is darker. A at 0, 1, and I'm going to want to go ahead and make that the letter A. And B is at 1, 2, 3, 1, 2, 3, 4, 5. So one thing that I always like to do is kind of, when I'm graphing, is using some common sense. Where would B be? Would B be down here? No, because M's in the middle. B's got to be somewhere up in here, right? B's got to be somewhere up in here. So I'm going to use my concept of rise over run. Remember, M is the middle. M is the middle. So I'm going to count 1, 2, 3, 4. 4 up, 1, 2, 3 over. This time I'm not dividing by 2 because I'm counting from end to middle. So I'm simply going to count it again. I'm going to count up 1, 2, 3, 4, and then I'm going to count over 1, 2, 3. There's B. Now I just have to figure out what that ordered pair is. Well, it's 1, 2, 3, 4, 5, 6, comma, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so remember, counting left to right is your X value, counting up, down from up is your Y value. Let's do that one more time. So the midpoint of CD, of segment CD, is M -1, positive 4. 1, 2, 3, 4. So there's M. There's my M. What are the coordinates of C if D is at 3, 1, 2, 3, -2, 1, 2. So there is D. All right, I'm going to connect them together. Remember, this is one end going to the middle. C's got to be somewhere up there, right? As I know that I'm going up this way, and C's got to be somewhere up there. I'm going to use my rise over my run. Since I'm counting from end to middle, I count, and then I count again. So I'm going to go 1, 2, 3, 4, 5, 6, and I stop when I'm even with the M. 1, 2, 3, 4. Let's count it again. 1, 2, 3, 4, 5, 6, all the way at the top. 1, 2, 3, wait. 1, 2, 3, 4. There it is. There's C. I'm going to guess that's 10 for my Y value because the last time I counted it, it was 9, and I was almost to the top. But let's see. Let's count over. 1, 2, 3, 4, 5. Since I counted to the left, I am at -5. -5. And then I'm going to count up to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. Google yourself a graph at 10 by 10. You can plot the points on it. You could go to Desmos.com and you could plot the point on an X and Y graph, and it would go ahead and help you out, okay? All right, so that finishes up our midpoint, but the other part of our lesson today are bisectors. So let's talk about bisectors. Here we go. A bisector is something that cuts, let me zoom out. There we go. A bisector is something that cuts an object into two equal parts. I can have two types of bisectors. The main two types that we will talk about are the segment bisector and the angle bisector. Now, just some things about a segment bisector. I could use the words that this line here that contains the point M is a segment bisector of segment AB. And I could just use the word. Or I could use this symbol. Okay, if I put the little hash marks between A and M and between M and B, that indicates that M is the midpoint and that those two pieces, A to M and M to B, are equal in length. That's what that is universally understood to mean. In my angle bisector, if this angle or if this ray that's coming through the middle of my large angle is right in the middle of angle ABC, then I could tell you it is a bisector of the angle, or I could put the marks like so. And I could do it in two ways. I could do it simply like that, or sometimes I like to put the little hash marks just to make sure that you understand these two pieces are equal. So the way that I can do that, I can simply use the word bisector and I don't have to mark it, or I could mark it and not use the word bisector. Okay, for the beginning part, I'll probably do a combo. I'll probably mark it and use the word, but I will for sure use the word. Okay. All right, I have two examples, one for segment, one for angle. Here we go. Segment Y, or WY, bisects segment UV at Y. Find the value of X. Find the value of X. I forgot to grab my orange highlighter, so I'm going to try this. Oh, well, I could try this. Hold on. Okay, so if I go back to my segment addition, I knew to take this, right, I'm going to wait a second, plus this piece, right, equals this one up here. I'm going to use my orange marker. Right? The yellow plus the pink equals the orange. That's what we learned in lesson 1.2, segment and distance, I think it was. And we learned the segment addition postulate. If I go ahead, though, and set up the segment addition postulate, I'm a little worried because there's no pink. I don't see any pink on my picture. I'm going to go ahead and set it up because that's the only thing I know how to do right now. That's the only thing I can think of right now. And while I'm setting this up, I'm kind of rereading my problem. Did I miss something? Well, yes, I did. Yes, I did. I missed something. I missed this word right here, bisect. This segment right here is bisecting the yellow and the pink. What does that mean? This part and this part are the same. So they didn't write down x plus 3 for me again because they expected me to know it because of the word bisects. See how geometry can start to trick you? Okay, now I know how to do this. I'm just going to go ahead and solve for x. So I'm going to combine together my x's on this side, giving me 2x. And I'm going to go ahead and combine my 3 plus 3 to give me 6. Now I'm going to go ahead and I'm going to move the 2x from this side over here because I like to keep everything positive. I find that I make less mistakes when I keep things positive, okay? 6 minus 2, I know that's 4. See, if I'd done it the other way, I would have to go to my calculator. Now I'm going to add my 10, and in geometry, it really doesn't matter where the x equals is. We just need to find x, that's all. Divide by 4, because I always divide when I see a number with a variable right behind it, and 16 divided by 4 is 4. I was just asked to find x, so I'm done. The only other thing I could ask you to do is to go back and plug it in, plug it in, plug it in. That's all I could do, okay? And I won't practice that with you today. All right, one last one. Let's go ahead and do this on an angle. Let's go ahead and do this with an angle. So if you noticed, yeah, I'm going to read it. Of course, you want to read the problem. But the first thing I could do, even before I start reading, is grab my highlighters and say, well, this part of my angle is yellow, and this part of my angle is pink, because we just learned this in the last lesson. And the whole angle together is blue. So I know that the yellow plus the pink equals the blue. And I'm going to wait and come back because I haven't read yet. Ray FG bisects angle EFH. Find the value of x. I heard that word. Bisects. That means that this ray right here, FG, is cutting the big blue angle into 2 equal pieces, which means this angle and this angle are exactly the same. Why is the blue angle not there? Because you don't need it for this one. In this case, because of the word bisect, I only need the yellow and the pink. And the word bisect says they are equal, okay? The word bisect kind of like supersedes the angle addition rule. It says don't use the rule, use me. 5x minus 10 equals 3x plus 26. Okay, so 2 ways that I could use bisect. I'll just talk about it while I go ahead and solve this equation. You could see that I used bisect with its definition here in example 4. In example 3, the way I used bisect was to make you use the property, the postulate, the rule that we learned in a previous lesson, and to duplicate. So bisect can make you duplicate. Bisect can say we're equal. You just have to know what you have in your picture. Okay, you just have to really look at what you have in your picture, and that's where your highlighting is going to help you out quite a bit. Okay, you could also use crayons or markers. I just like highlighters because I can write in them. So I got 18. Okay, all right, we'll see you again next time.